We've been working with marginal analysis and, excuse me, I want to run through one more example of computing the elasticity of demand. So on page 212, number 31, we've got this demand equation, P equals 169 minus x squared, and we're interested in a price point of $29. So to compute elasticity, the first thing we need to do is find that function f of p. And to do that, we solve this equation for x. So if we do a little algebra here, we get x squared equals 169, 169, not 119. 169 minus p, and then solving for x, we're going to take the positive square root of 169 minus p. We don't need the negative value because our x stands for quantity demanded, and that value can't be negative, so we're dealing with positive numbers. Okay, so what we've established is that f of p is the square root of 169 minus p. Now besides f of p, we also need f prime of p for the formula for elasticity. So I'm going to take the derivative of that function. Another way to think of the square root of 169 minus p is to think of the quantity 169 minus p raised to the 1/2 power. And then we can use our general power rule, our chain rule, to take that derivative. So that derivative would be 1/2 times 169 minus p to the negative 1/2, because we reduced that exponent by 1. And then because of the chain rule, we have to multiply by the derivative of 169 minus p, which is negative 1. When you simplify that, that ends up looking like this. Negative 1 over 2 square root of 169 minus p. That negative 1/2 is still a radical, but the negative sign moves it to the denominator of the fraction. So that's a simplified form. And then for our formula, we need to plug 29 into each of these functions. So I'm going to find f of 29 by plugging 29 into this function. 169 minus 29, that's 140. So this is the square root of 140. And I'm not going to worry about a decimal value right now, but you can if you want to compute that. For f prime of p, f prime of 29, I'm going to do the same thing, plug 29 in there. And this time we get negative 1 over 2 square root of 140. And these are the values that we're going to use in our elasticity formula. So now that we've done the work to compute f of 29 and f prime of 29, we can write out our elasticity function, just using that formula that we've been working with. So E of p is the function negative, or the opposite of, p times f prime of p, which is negative 1 over 2 square root of 140, divided by f of p, which is the square root of 140. Okay, so we're going to do a little algebra to simplify this function, and that works out to be a positive p on top and 2 times the square root of 140 times the square root of 140 in the denominator. And when you simplify that, you get p over 280. So our elasticity function, E of p, simplifies to p over 280. So if we know the price, we're going to divide by 280 to compute the elasticity for this problem. In our case, we want to do E of 29. I'm going to get a clean screen and finish this off. So our elasticity function is p over 280. we want to compute the elasticity at a price of $29. So I'm going to plug 29 into this formula. 29 divided by 280. And, if you crank this out on a calculator, this is about 0.104 rounded off. So that's the elasticity. And since this value is less than 1, I will say that the demand is inelastic at $29. So that's a brief example. Keep the questions coming, and good luck with the rest of your problems.